Hi, so today we'll learn about the new topics, which is SQL data definition language. So here we will start from SQL dialects, implementing the design, attributes, data types, creating table, primary key, foreign key, how to check constraint, how to make changes, how to drop a table, other schema objects, and the last one, summary. It all started with Edgar F. Codd publishing a paper called A Relational Model for Data for Large Shared Database in 1970. His data model was highly structured, but also flexible enough to accommodate relationships between entities. These properties were very extensive in a time when electronic processing of data became accessible to mainstream companies. Until then, most companies did all of their bookkeeping on paper. When the relational model was invented, IBM and Oracle immediately started working on implementation. It became clear that scripting language was needed to access such database. By 1974, IBM has produced the structured English query language, which is why many people still today mispronounce the name of SQL. The name was changed to SQL in 1976 for legal reasons. SQL was standardized by the ISO first in 1989, but drastic changes were still made before the third version. The 92 standard was published. There is also 99 standard, which contains additions that mainly deal with object-oriented addition to the model, but it has also added support for regular expression. There is also SQL 2003, 2008, and also 2011, all standards that deal with SQL extension. Essentially, all you need to know about the SQL is in the SQL 92 standard. As you can see, a lot of data were developed way before the 92 standard that cleaned up many inconsistencies in the SQL language. Oracle Corporation got started on their database in early 70s, and IBM DB2 was delivered at about the same time. Sybase is a product that started in 1984, and MS SQL Server was started in 1988 based on Sybase code. So it comes as no surprise that none of them are 100% compliant with the SQL standard. The initial version MySQL was published in 95, but it isn't 100% compliant either. Depending on the feature you use, you may have to change your embedded SQL if you migrate your data to another database product. This phenomenon is often referred to as each database product has its own SQL dialects. In this slide, we use SQL according to the standard. You may have to adjust your syntax when you run statement against an actual database. Having designed the database relation model using entity relationship diagram, it's time to implement the design on an instance of a database server. Each entity in the relational model becomes a table in the database, and each attribute becomes a column in the corresponding table. If you are making a brand new database, you may want to create the database first. As instance of database server can have several databases, you will have group of entities that have nothing to do with each other. It is best to make database for each of them. Each database has its schema. A schema is a structured description of your database. So you can use ER diagram or UML diagram to describe the database schema. Within the database, we create the schema object we need. Schema object are table, index, views, triggers, and so on. The part of SQL which let you define schema object is called data definition or DDL. When you create a new table, you have to create its number attribute as well. Attribute is meaningful names so people understand what the attribute is about. There are few technical rules for naming attribute. Attribute name must be string of characters which consist of uppercase or lowercase letters. Design and underscore. Attribute names cannot start with a number. You can have expressed in attribute names. Apart from these technical rules, you should make your own naming convention. Many people prefix a column name with the table name. Like in the example, all database use underscore to connect two parts of a name. More recently, people have started using camel notation like in Java. We can use capital letter for column names, but it's more unusual. People often start the table name with capital letter, but the column name with the lowercase letter. Whatever you do, stick to one style. Don't mix or database looks really messy. The SQL standard define quite a large number of data types, many more than mentioned here. Each database product implement this slightly differently. So when you start implementing your database, investigate the data type of your database product first. For example, MySQL has its own implementation of standard type, but then it's also of a type that are not mentioned in the standard. Sometimes this counter type work exactly the same as the type from the standard. MySQL has at least double as many data types as the standard. On the slide, there are also a few select ones. MySQL has medium in and begin, and you can use integer and specify the number of bytes that you want. There is also numeric and it works the same as decimal. Trying to remember them make little sense. What you should remember tough is that some number will be imprecise. Because of the conversion to binary and limited precision, this number marked approximately will be not 100% accurate all the time. If you need to expect monetary values or other items where we cannot afford to have imprecise values, use decimal, not float, real, or double. And the fact is that with integer, you can have a signed and unsigned version. If you specify nothing, the default is signed. Sign means the first bit in the number is used to signify whether the number is positive or negative. If you know exactly that your number can never be negative, it makes a lot of sense defining it as unsigned. Most of us can do unsigned, so look into this as well. When you create a database, you attribute where you cannot guarantee that you always know the value for them. This kind of empty value is called a null value. Null value often cause headache in SQL queries. They give rise the Trinity logic. Binary logic is true, false, the Trinity logic is true, false, and unknown. But we get into this when we talk about queries. Null means we don't know the value yet. Perhaps we never know it. Perhaps we just have not asked yet. There's many situations where you cannot be sure your database will ever have a value for a field. You might think let's just exclude such field, but this is not always an option. In the example, we have a gender field in the customer table. Many companies like to know the gender of their customer for targeted marketing, but a company cannot force its customer to reveal their gender. We could decide to exclude attributes that are not guaranteed to have value, but this may be counterproductive. For example, most people will volunteer their gender without ever thinking, and you will miss out on the information if you abolish the gender field. You can say the gender field should have a default value, but it has other problems. If we say the default is female, for any field that has a value of female, we cannot actually say whether this value came from a customer answer or was made up by the DBMS because there was no value. Consequently, rational DBMS allow null values, and people use them all the time. But null values are problematic in some queries, and we look into this later. For now, all you have to know is that you should make as many fields as not nullable as possible. Now that we know the basic about naming and typing attribute as well as null value, we can look at the SQL syntax for creating a table. The syntax is easy enough. The data types are stricter. You have to decide whether a field is large enough to capture all possible values. Looking at the number for start ID, we will think that 7 will be more than enough, but you may enroll a lot of students for the years. So it may be safer to have an integer. Chances are that in, which is integer, is only 4 bytes longer. We don't worry about storage space on this scale. What we know for sure is that negative values are out of the question for field ID. So we make the number unsigned. This double the number of possible entries. So small int might actually be long enough. If you use the MySQL data type, you may want to use an integer specify the number of bytes it should use. Subject ID is also an ID field, but in this case it contains letter. So all we can do is make it character data because the variation in length is really insignificant. We might as well make it car or not bar car. Semester year are fields that are numeric, but you never use them for calculations. So you might choose to make them character string. The mark field is clearly a decimal value with a scale of 1. If you use decimal in MySQL, we know there won't be any floating point errors. For any other database, you will have to check this. Red is clearly a character string of length 2. Using bata is not very meaningful because the values are either 1 or 2 characters long. So saving space is not a great advantage over having a steady length field. You can simply say that student ID, subject ID, year and semester are compulsory values that must be known from the start. There is no enrollment if we don't know who the student is, what subject we are enrolling her in, and for what semester. The mark and grade are different. In the beginning of this semester, they will be unknown. Therefore, these two must be nullable. The table we created just now is perfectly usable. You could begin to insert data into it. But you may remember that some fields in the ER diagram were specified as primary key. In the case of enrollment, we had a composite primary key that included student ID, subject ID, year, and semester. The create table statement should always contain a primary constraint, although ID field can be used without imposing a primary key constraint. The constraint ensures that there will be no duplicate value. Primary key constraint will also make sure you specify the not null with the column. If you don't add the constraint, something might go wrong and you might have duplicate entries. This is the problem when you expect a field to be unique identifier. All of a sudden, you might have a student enrolled in the same subject twice in the same semester. When you run a count over student enrollments, the number won't match up. Doing a lazy job when defining data structure usually results in a lot of detective work down the track, and they spend sorting out discrepancies as well as to explain the problem to the boss. Similar to the primary key constraint, if you impose the foreign key reference in the table implementation, the DBMS makes sure you cannot state a value that does not exist as a primary key in the reference table. This ensures that there are no orphan rows in the child table, but you have to beware that if you allow null value in the foreign key column, the DBMS will allow null even if it is a foreign key column. This means that operand rows can still exist. However, any value that other null will be matched against a primary key in the parent table. Allow null value with foreign key if you can. The relationship between tables exists even if there is no foreign key constraint. You can still match the row on the foreign key column, but like in the case of the primary key constraint, missing constraint always present a risk of database corruption. The database can stop a wrong value from being inserted when there is no foreign key constraint. Foreign key ensure the referential integrity of the database is preserved. Check constraint let you specify a log value for columns. You can also use unique constraint by putting the keyword unique behind an attribute declaration. This means although the column is not a primary key, the DBMS will take care that no duplicate values appear in the column. The default keyword is not a constant rather than tools that let you specify a value when we don't know the actual yet or when most of the time the attribute is set to a particular value. This is helpful when you don't know the actual yet but don't know to allow null with the column. When you add row to the table, you cannot omit the attribute where the default value and the database will apply the default. This is a good way for avoiding null value. but it was only if there is a meaningful value that can be the default. The alter command lets you make changes to existing tables. Students tend to avoid it because in a practice environment, you have the option of eliminating and recreating tables. Production database don't have this advantage. If you need to add remove another column, you need alter table. Using alter table, you can also add permanently and other constraints. The answer show the standard syntax which gives the constraint a component. MySQL also have a shorter version with a constraint. If you need to eliminate a table from your schema, you need to use the drop command. Using the drop command is a serious matter in real life since once table is dropped, it cannot be recovered. Therefore, you must make sure that it is safe to do this. Even when even asks you whether you sure want to do this, the table just disappears. Having said that, if the table was set properly including the appropriate user rights, you shouldn't be able to do this as DB user, normal DB user. In the case of student table, it's actually quite likely nothing at all will happen when you try to delete it. You get some kind of error message that you may or may not be able to make sense of at this stage. The issue here is that there are foreign key referred in the enrollment table, which is table child, which is the table child that point to the parent of table student. Now, if you are stupid enough not to put in any foreign key constraint, this will make no difference whatsoever. The table will just disappear and we have not often rows in the element table. If you didn't implement the foreign key constraint, chances are the delete won't happen. Although this depends on the database product. More precisely, it depends on the referential integrity rules applied. Most users don't specify referential integrity rules when implementing a foreign key constraint. This only means that the VMS applies default, which in most cases is on delete no action. The mission integrity rules actually specify what should happen when you delete a row in the parent table, which is the tables to the table here. On delete no action means the deletion of the parent row will be stopped if the row has child rows in enrollment. On delete cascade is the most dangerous. It means all child rows disappear as well. This is very dangerous rules, especially if the child table has other child table. But if the child of the child specified on delete no action, the scaffolding will be stopped and nothing happens after all. In short, referential integrity rules seem simple but are actually quite complex in the practice. That's why you are not expected to master them here. You only expected to remember there was such a concept when you are making your own database. When you remember that this rule exists, you know how to explore this option for your database product. Although the referential integrity rule is designed for this, in most database products it will also affect dropping the entire table. Students therefore tend to skip implementing foreign key, which is not recommended. If you need to drop tables, you just have to drop the child table first, dropping enrollment, and the student won't give you any problems. If this is not convenient, you can temporarily disable foreign key constraint in MySQL by setting the variable foreign key check equal to 0. Schema are objects that are part of database. In fact, database and schema are often used interchangeably. Schema is standard term. Most VMS let you create database instead of it in addition to schemas. The list is the part of SQL that let you define your database. So it comes as no surprise that the DDL statement, create, alter, drop are used to manipulate schema objects. You know what a table is? A domain is a custom data type. If you have many columns that have the same data types and perhaps constraints, you may want to define a domain to make defining attribute easier. But this is not something you need to remember. Users usually badly understood and underused. But we will have talk about them later because we have to learn about queries. In this structure can help make queries faster, but we have to talk about them discussing queries. So finally, we have a sixth conclusion here. SQL has two components, which one is a database data definition language and data manipulation language. Second one, data definition language has three major statements that let you define your database structure, which are create, alter, drop. When creating a table, each column must have a data type that defines the value that it could store. Don't skip implementing primary and foreign key constraints. Dropping table must be carefully planned. Dropping a table may not succeed when child rows reference is doubled. Dropping child table first is one way to fix this. Disabling foreign key constraint is another. So as a tutorial, this question is all about the how to write regular expression that match the valid integer numbers only. Although this question is not related with this week lecture, but however, this question is related with our test, which is maybe this question will come out the test. So I will post this question in the Canvas discussion with 3 lectures left. So I hope all of you can contribute the answer regarding on this, because lately I just received the email from the university management, which is they will monitor our campus. So that's mean previously we have some kind like a student participation in class, but however this time they will measure student participation in Canvas. So I think by giving this kind of material, I think it's a good way to let you to participate in the Canvas. So it's good for you. Okay, I think that's all for the lecture for this week. Okay, thank you.